Hey guys, in this video I will be showing you how to control a heavy-duty linear actuator using an Arduino and an L298N motor control board. Before we get started, I'd like to give a special thanks out to all of those of you who have been watching my videos, and a special thanks to the 158 of you who have subscribed to my relatively new channel. And to those of you who haven't subscribed yet, I would encourage you to look through my videos, check out videos such as my CNC Etch-a-Sketch project, and if you find my videos interesting and useful, I would encourage you to subscribe to my channel. My goal is to get 1,000 subscribers by the end of the year. In a previous video, I used the L298N motor control board along with an NJK 5002 magnetic proximity sensor. In this video, though, I'm going to be using the L298N and a 3-button switch. In a future video, I will show you how to control the linear actuator using an RC transmitter and receiver. So be sure to subscribe to my channel and click that notification bell so you don't miss that episode. Instead of using a power supply, this time I will be using a 12-volt sealed lead-acid battery. I want to mention really quickly the differences between the L298N and the L298N motor control boards. As you can see, the L298N is quite a bit smaller, costs quite a bit less, but can't handle as much power as the L298N. That is why I used the L298N in my solar tracker project. The L298N can handle about 4 times the power. It does cost more, but one other advantage that I like to mention is that it has a built-in 5-volt regulator. So we can connect our battery directly to this board and pull 5 volts off this board to power our microcontroller. Let me go ahead and explain my connections. First of all, I've got the positive and negative coming from the linear actuator to the out 1 and out 2 pins on the motor control board. I've got positive and ground coming from the battery. I've also got this little pin here, which is 5 volts going to the breadboard and ground going to the breadboard. This will power my switch and the Arduino. And then connected to pin In1 and In2, I have digital pins 9 and 10 on the Arduino. On the switch, I have 3 10 kilo ohm pull-up resistors, pulling the 3 pins up to 5 volts, and the common leg of the switch is going to ground, and then the digital connections are pins 2, 3, and 4. Let's go peek at the Arduino code. Let me describe this simple little code. We have our retract, extend, and stop buttons as pins 2, 3, and 4 on the Arduino. Also extend and retract pins as 10 and 9 respectively. We're going to declare our button pins as inputs and our extend and retract pins as outputs, and we're going to start out by writing low so that the actuator doesn't move when we first boot up our code. Okay, now down here in our loop, we're going to check the retract button. If it's low, we're going to command the retract pin high and the extend pin low. We're going to check the extend button and see if it is low. If it is, we're going to set the retract pin to low and the extend to high. And if the stop button is pressed, we're going to set both retract to low and the extend to low. Then we're going to wait a quarter second and we'll check again. Alright, so I got my 3 buttons here. I'm going to push the extend button. As you can see, the actuator is extending nicely. We're going to stop it there and tell it to retract. Once again, we can also stop or change directions. Seems to be working perfectly. Now, I did use digital writes, but if you wanted to use analog writes, you could. That would also allow you to control the speed of the linear actuator. So that's the code, very simple. Like I say, I'll make it a little trickier next time by adding the remote control functions and see if we can control the linear actuator with the remote control. Once again, thanks for watching, and we'll see you next time.